It is Friday, January 18th, 2019. I'm never going to get over that, I swear. It is 8 p.m. Pacific Standard Time, and so you know what time it is. It's time for a little bit of coin metal. And as promised, we will be going through the Verge BlackPaper tonight. I kind of skipped ahead just a teeny tiny there. It was a glorious, or not so glorious as the case may be, get your ass kicked at Jiu-Jitsu Friday. We covered a little bit of passing the guard today with a couple interesting applications of the knee in the process. And I had a couple that felt really, really good. And I don't know. I wasn't able to actually implement them when we were doing sparring. I don't know why, but I kept getting swept by my opponent. I mean, instantaneously. I think it's because he was a little bit taller than me. So I don't know. I was just being stupid with my foot placement. It could go either way. Nonetheless, it was a lot of fun. I found a couple things that I really enjoyed doing as far as passing the guard, and the one was if you have your one of your opponent's legs between yours, shuffling off to one side, with your hand either like on their hip or on their abdomen, and shifting off to one side to get their hips to follow you, right? And then just pressing my knee straight in towards the ground from there. And then, just straight over the thigh. And I thought that was so fucking neat because it allowed me the kind of contact that I felt that I would have wanted to be able to subvert that hip, trying to roll into me or anything like that. But like I said, I had a lot of difficulty in actual implementation of this guard pass, and I think I ended up in the guy's guard and a few other things that were not me getting around his guard. And then he was able to resume his guard relatively well. I don't know why, but I was really burning out today really quick. Honestly, I think it's because it's my, 1, 2, 3, 4, 5, 6, 7th jiu-jitsu class for this week. I did Sunday, Monday, 2 on Tuesday, none on Wednesday, 2 on Thursday, and then 1 today. So yeah, I got in a lot of jiu-jitsu this week. And I really think that's what it is. It's just overall fatigue. My brain, the last 2 times I went this week, my brain wasn't entirely engaged, and my body was only slightly more so. But I think it's one of those things where I'll go through this for maybe like a month or so, and then I'll start really getting my longer term wind or something. I don't know. But my experience with my body has been this, that if I don't push, I don't get results. If I don't push my endurance level by going longer, then I don't make any progress. If I don't push harder as far as intensity goes, that part of my game suffers as well. And I'm a slower mover to begin with, so I've been trying to bring up my tempo, and maintain my game for longer. And unfortunately, I think I was managing about 3-minute spurts, and then my opponent cardio tapped me at least once. But I did try and stay with it and at least finish out that 5-minute round, and that was doable. It was a little bit difficult towards the end, but nonetheless, I did not roll with people that were under my belt level today, except for one, but he's huge. Anyway. So it's back to that idea again of trying to really push my proficiencies, and I didn't really feel like I was getting anywhere by just rolling with white belts, because if anything, it was just self-preservation, trying to keep myself from getting tapped. And but it wasn't really pushing me forward as far as seeing the opportunities. And even now, I'm still a little bit more intimidated with a proficient player and not really paying attention enough to what my body position is and what their body position is in going through with closing out like a submission. Like I had my one opponent who was a blue belt, or is a blue belt rather. I managed to, after he swept me, I managed to catch him in what would have been a good ankle lock or leg lock. Yeah, I think a leg lock. I don't spend enough time actually doing legs to know all the names of them yet. I think it was more like an ankle lock rather. But I was pretty damn close to it. And I didn't have the right grip on his ankle, and he was able to roll it in. The fact that I even got that far towards a submission made me feel pretty good that, I at least caught it. But yeah, so it was a lot of fun. Yesterday's first, what did we do yesterday? Man, I'm having an impossibility trying to remember all of it today. Anyway, let's go ahead and throw down into some music. And as far as our first dance goes, we haven't been opening up with body count, and I feel like that's a travesty. We just got to do it. So here it is, Bloodlust, first dance here on Coin Metal. And that was Rivers of Nile, where owls know my name. Anywho, as far as what we're getting into tonight, as promised, the Verge BlackPaper. And I just got to jump right into it because it's 30 pages long, and I'm really hoping for a lot of illustrations at this point. I mean, the first page is mostly an illustration, so that's we're off to a good start, right? All right, BlackPaper, Verge Currency, 5th edition. Introduction. Since its inception in 2009, Bitcoin and the concept of a blockchain was developed in response to an inherent flaw in the way transactions were processed on the internet. In his white paper, Nakamoto explains that, quote, commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. While the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. Bitcoin has been rapidly adopted into today's modern marketplace. A primary issue with Bitcoin's rapid adoption is the increase of demand on the original blockchain to handle varying degrees of large transactions. With increased demand comes increased transactional waiting periods, and this has resulted in higher transaction fees in attempts to try and speed up transaction confirmation times. And hold on one second, I gotta make a minor adjustment here. Thank goodness for background music, right? Anyway, continuing on, table of contents, blah, 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 blah. We're not going to do it like that. Oh, cool. We're on page 4 already. 1.0, overview. The core innovation behind Bitcoin is its decentralized structure. Unlike traditional fiat currencies, Bitcoin has no central control, no central repository of information, no central management, and no central point of failure. I'm not so sure about that, dude. To this point, Verge was created to bring tailored transactional applications and inherent privacy implementations to strengthen user obfuscation while maintaining Nakamoto's vision of a decentralized electronic payment system based on cryptographic proof instead of third-party trust. 1.1 Multi-algo POW. Verge is a multi-algorithm enabled proof-of-work based cryptocurrency that is designed to enable people with different types of mining devices to have equal access to earning coins. It is one of the few cryptocurrencies to support 5 hash functions combined on one blockchain. This results in an increased security due to a wider range of people and devices that can mine Verge. The 5 algorithms supported on the Verge network are Script, X17, Lyra2, Rev2, Mir-Grussel, and Blake2S. All 5 algorithms have a 30-second block target time, and the difficulty is influenced only by the algorithm's hash rate. 1.2 Tailored Transactional Applications. Verge was originally created based on the idea of proving end-user identity obfuscation suited for everyday use, We believe that every human being deserves the right to privacy, and that with that idea in mind, we pride ourselves on being able to provide several different available methods of transacting across the Verge network. Each method provides our users with a base level of obfuscation through the Tor network, as well as different obfuscation options tailored for everyone's specific needs. 1.3 Simple Transactions. Much like Bitcoin, the Verge network operates on a publicly facing blockchain. It is important to understand that all transactions are stored publicly and permanently on the blockchain. This means that anyone can see the balance and transactions of any Verge address. However, Verge addresses are not themselves linked to a person or entity, and users remain pseudo-anonymous so long as different addresses are used per transaction and/or until information is revealed during a purchase or other transactional circumstance. REF? These styles of transactions are best suited for general everyday use. 1.4 Stealth Transactions. Stealth transactions are primarily compromised, that's not the right word, dude. Primarily composed of dual key stealth addresses. As you will read later on in this paper, stealth addresses are a method by which additional obfuscation can be implemented to further protect the receiving party when transacting with Verge. This is done by requiring the payers to generate random one-time addresses for a given transaction. When multiple users send funds to a stealth address, rather than these transactions appearing on the blockchain as multiple payments to the same address, they instead appear as multiple payments going to different addresses. This, in theory, makes it near impossible to link transactions to the recipient's published address or one-time generated addresses. I need to make a minor tweak on this. Where the hell is... There we go. There we go. Let's see. And in theory makes it impossible to link transactions to the recipient's published address or one-time generated address. It is important to note that this type of transaction is designed such that the recipient of a payment can maintain their privacy. Stealth addresses do not provide 100% anonymity and do not protect the sender. 1.5 Anonymous Transactions. Anonymous transactions use a combination of dual key stealth addresses and ring CT, ring signatures, and confidential transactions to preserve the anonymity of both the sending and receiving parties. These concepts will be explained later in this paper. However, the short version is that ring signatures make it harder to trace transactions by obscuring the output of the true sender and a set of other outputs on the blockchain. Confidential transactions hide the actual amounts being sent, and Tor hides both parties' true IP addresses, i.e. IP obfuscation. This style of transaction is best suited for those who are fully looking to maintain their personal privacy. 2.0, the Verge Network. The following segments are to discuss key integrations that are supported on the Verge Network. 2.1, Tor integration. Tor derived from an acronym for the original software project name, the Onion Router, is an IP obfuscation service which enables anonymous communication across layered circuit-based networks. Tor directs internet traffic through a free worldwide volunteer overlay network consisting of more than 7,000 relays to conceal a user's location and usage from anyone conducting network surveillance or traffic analysis. The layers of encrypted address information used to anonymize data packets sent through Tor are reminiscent of an onion, hence the name. That way, a data packet's path through the Tor network cannot be fully traced. Tor's use is intended to protect the personal privacy of users, as well as their freedom and ability to conduct confidential communication by keeping their internet activities from being monitored. Onion routing is implemented by encryption in the application layer of a communication protocol stack, nested like the layers of an onion. Tor encrypts the data, including the next node destination IP, multiple times and sends it through a virtual circuit comprising successive randomly selected Tor relays. Each relay decrypts only enough of the data packet wrapper to know which relay the data came from and which relay to send it to next. The relay then rewraps the package in a new wrapper and sends it on. The final relay decrypts the innermost layer of the encryption and sends the original data to its destination without revealing or even knowing the source IP address. In short, when a user connects to the Tor network, their internet traffic is then routed through a number of global servers, each of which removes information from the previous server such that the last exit node server ends up being clueless as to where the network originated from. 2.2, I2P integration, was originally built to provide hidden services which allow people to host servers at unknown locations. I2P provides many of the same benefits that Tor does, both allowing anonymous access to online content, make use of a P2P style routing structure, and both operate using layered encryption. However, I2P was designed to be a, quote, network within the internet, with traffic staying contained within its borders. I2P performs packet-based routing as opposed to Tor's circuit-based routing. This provides the benefit of permitting I2P to dynamically route around congestion and service interruptions in a manner like the Internet's IP routing. This provides a higher level of reliability and redundancy to the network itself. The first time a client wants to contact another client, they make a query against the full distributed, quote, network database, a custom structured distributed hash table, DHT, based off of the Kademlia algorithm. My apologies, that's a weird word. This is done to find the other client's inbound tunnels efficiently, but subsequent data between them usually includes that information, so no further network database lookups are required. And then there's a nice diagram. 2.3, Electrum. Electrum's strength is speed and simplicity with low resource usage. It uses secure remote servers that handle the most complicated parts of the Verge network and allows users to recover their wallets with the secret seed phrase. Additionally, Electrum offers a simple and easy-to-use cold storage solution. This allows users to store all or part of their coins in an offline manner. Moreover, Electrum is one of the only wallets to provide native Tor and I2P support. By integrating Electrum with Tor and I2P, one can achieve anonymity while using the desktop/mobile wallet. Both IP address and transaction information is secured and does not leak to the connecting servers, increasing user privacy. Electrum enables multi-signature support, which requires more than one key to authorize an Electrum transaction. Standard transactions on the Verge network could be called single signature transactions because transfers require only one signature from the owner of the private key associated with the Verge address. As an Electrum transaction with multi-signature support requires the signatures of multiple people before the coins can be transferred. Verge then requires multiple different party addresses to be provided to do anything with them. One Electrum wallet is on your primary computer, the other on your smartphone. The coins cannot be spent without a signature from both devices. Thus, an attacker must gain access to both devices in order to steal your funds. 2.4. Tor Android. The Verge Tor 16,10 wallet was designed to bring IP obfuscation services to your personal mobile devices when transacting with Verge. This wallet, by default, does not have the ability to connect to or broadcast user information over ClearNet, which helps to ensure that no user data is unintentionally leaked. All transactions are completed over Tor via Simple Payment Verification, SPV. SPV is a technique described in Satoshi Nakamoto's white paper that allows for the wallet to verify transactions through proof of inclusion, a method for verifying if a transaction is included in a block without downloading the entire block, similar to how an Electrum wallet functions. SPV allows for nearly instant payment confirmations because it acts as a thin client that only needs to download the block headers, which are drastically smaller than the full blocks. The Verge Tor wallet also houses standard security features, such as a 4-digit PIN code and biometric locking options for an added layer of physical security. Additionally, the Verge Tor wallet can handle P2P QR code scan transactions with instant verification. Clients can also import QR codes from paper wallets to pull balances from cold storage if required. 3.0. Encrypted Messaging. Encrypted messaging is a peer-to-peer instant messaging system utilizing state-of-the-art encryption technology to keep your communications private. All messages are encrypted by the proven AES-256-CBC algorithm and distributed between nodes in such a way as to prevent the recipients of messages from being interfered by assailants utilizing sophisticated traffic analysis. Encrypted messaging utilizes the elliptic curve digital signature algorithm, which is a variant of the digital signature algorithm used in elliptical curve cryptography. ECDSA is used to give you the confidence of knowing messages you receive come from the original recipient and remain untouched in propagation. You might want to review the episode I did called "Dude, Are These Your Private Keys?" It talks extensively about ECDSA and I think it's possible compromises within it, depending on which way that you go about utilizing it. Continuing on. As with stealth address transactions, the elliptic curve Diffie-Hellman key exchange method allows a secret key for encryption to be shared between the sender and the recipient using the data embedded in the message along with the private keys of Verge dual key stealth addresses held by the sender and recipient, thus allowing for the distribution of messages of whom nobody knows the recipient of. In order to send an encrypted message, much like sending Verge, you must possess the public key of the intended recipient. Verge uses curve SECP-256K1-27 for all and that's reference 27 for all elliptic curve functions. This is the same curve used by Bitcoin along with most altcoins. With such widespread use and underpinning systems of immense value, it is extremely unlikely that curve SECP-256K1 is not secure. That's not necessarily an appropriate logic to put to that, dude. Because we're talking about money, and so the incentive structure behind money is a whole lot different. And so it's a matter of there's suddenly a major incentive that if you crack it, you're able to take possession of the funds and the keys, or that are associated with the keys. And so that, again, that changes the incentive structure of trying to crack any particular algorithm or securing means, whichever it may be. So yeah, anyway, continuing on. This allows you to be confident of the origin of the messages you receive and allows the public key of the sender to be extracted from the message, providing you all the information needed to send a reply. Additionally, our implementation of encrypted messaging takes full advantage of both LZ4 and XX hash algorithms. LZ4 is a lossless data compression algorithm that is focused on compression and decompression speed while simultaneously utilizing very little compute resource. LZ4 is the primary compression algorithm used in many modern-day applications such as ZFS on Linux, FreeBSD, Illumos, and many others, which can be found here, and there's a little link there. XX hash is an extremely fast, non-cryptographic hashing algorithm with working speeds close to RAM limitations. Combining XX hash with LZ4 compression enables the Verge network to very quickly send and receive messages over the blockchain with very little limited impact on the compute and network resources. 3.3 Message propagation. Encrypted messages are duplicated on every participating node in the Verge network. This prevents adversaries from uncovering the recipient of an encrypted message by using network traffic analysis. The messages are stored on each node for a maximum period of 48 hours, after which the message is deleted. If the recipient is absent for the network for 48 hours or more, the possibility exists that they may not receive messages sent to them. It is recommended to connect to the network each day in order to prevent such an occurrence. Stored messages are grouped by time in divisions of 1 hour. The system operates on the grouped buckets of messages to save bandwidth. 4.0 Dual key stealth addressing. Stealth addressing allows senders to create an unlimited number of one-time destination addresses on behalf of the recipient without any interaction between the parties. Stealth addresses are a method by which additional obfuscation can be implemented to further protect the receiving party when transacting with Verge. When multiple users send funds to a stealth address, rather than these transactions appearing on the blockchain as multiple payments to the same address, they instead appear as multiple payments going to different addresses. This in theory makes it near impossible to link transactions to the recipient's published address or one-time generated addresses. This is achieved through a system of cryptography known as elliptic curve, or more specifically in this case, elliptic curve Diffie-Hellman, ECDH for short. ECDH works by allowing any two individuals who know each other's private keys to be able to communicate a shared secret that nobody else can either duplicate or link to either party's public keys. Due to the unique cryptographic properties of the ECDH algorithm, the shared key cannot be reverse engineered to arrive at either the sender or the receiver addresses. To understand how a stealth address functions, let's look at some of the key fundamental concepts that are involved in the process. 4.1 Dual Key Stealth Address Protocol. This protocol was designed to eliminate the continuous usage of the private spending key. These design flaws in the original stealth addressing protocol significantly increase the risk of said key being compromised. In order to eliminate private spending key overuse, Dual Key Stealth Address Protocol was introduced. This protocol introduces two pairs of cryptographic keys, a scan and a spend key, and computes a one-time payment address per transaction. In order to better understand how this works, let's review how this style of transaction takes place. Number 1, Marvin, the receiver, has two private/public key pairs, lowercase s and uppercase s, and lowercase b and uppercase b, where s equals s minus g and b equals b minus g are scan public key and spend public key respectively. Here g is the base point of an elliptic curve group. Number 2, Swen, the sender, generates an ephemeral key pair, lowercase r and uppercase r, where r equals r minus g or r times g, and transmits it with the transaction. Number 3, both Swen and Marvin can compute a shared secret C using the ECDH C equals h times r times s times g equals h times r times s, or uppercase s rather, equals h times s times uppercase r, where h, or uppercase h, is a cryptographic hash function. 4. Swen uses c times g plus b, or uppercase g plus uppercase b, as the ephemeral destination address for sending the payment. 5. Marvin actively monitors the blockchain and checks whether some transaction has been sent to the purported destination address c times uppercase g plus uppercase b. Depending on whether the wallet is encrypted, the receiver can compute the same destination address in two different ways, i.e., lowercase c times uppercase g plus b equals c plus b, lowercase c plus lowercase b times uppercase g. If there is a match, the payment can be spent using the corresponding private key, lowercase c plus lowercase b. Note that the ephemeral private key, lowercase c plus lowercase b, can only be computed by Marvin. With DKSAP, if an auditor or a proxy server exists in the system, the receiver can share the scan private key, lowercase s, and the spend public key, uppercase b, with the auditor/proxy server, so that those entities can scan the blockchain transaction on behalf of the receiver. However, they are not able to compute the ephemeral private key, lowercase c plus lowercase b, and spend the payment. Oh, there you go, man. That sounds like that would be the kind of implementation that would circumvent the attack method that we were talking about during that last episode of Dude, are these your private keys? I'm not sure, but maybe whoever did the report, and I titled the report in the description of that one, so if you do want to check that out, you'll probably be able to find the PDF by reading the description for that episode. But yeah, it's interesting stuff. Or you can just listen to it, because I read the whole paper except for the big math parts. I had to rehydrate. It's a long bitch. We're on page 14. 4.2 Key Agreements. A key agreement scheme is a procedure by which two or more parties agree upon a value from which they can subsequently derive one or more keys for use in symmetric encryption. Neither party completely determines the key value on their own. Instead, they both contribute to the final key value, and most important, anyone who observes the exchanges between the two parties cannot tell what the result will be. It is important to note that in their basic form, key agreement schemes are anonymous. They do not tell either party the identity of the other party. 4.3 The Diffie-Hellman algorithm. The original Diffie-Hellman key agreement scheme is based on multiplication of integers modulo a large prime number, specifically numbers greater than 1 and less than p, where p is a large number, a large prime. ECDH is an analogous scheme based on addition of points on an elliptic curve. In both schemes, the basic operations are combined to create a primitive function known as keyed one-way function. A keyed one-way function is a function that takes two inputs, one of which is private, ergo the key, and produces one output. Given the two inputs, it must be straightforward to calculate the output, but it must be computationally infeasible to calculate the key, using only the other input and the output. In this way, each party can use their private key without revealing it to anyone else, either the other party or an eavesdropper, man in the middle. 4.4 Elliptic Curve Diffie-Hellman, ECDH. ECDH is a variant of the Diffie-Hellman algorithm for elliptic curves. It is a key agreement protocol, which means that ECDH defines how keys should be generated and exchanged between parties. How to encrypt data using these keys is up to us. ECDH is implemented to solve the following problem. Two parties, Martin and Swen, want to exchange information securely, such that a third party, man in the middle, may intercept them but not decode them. Here's how it works. First, Marvin and Swen generate their own private and public keys. We have the private key d, lowercase d and uppercase a, and the public key uppercase H, uppercase A, equals lowercase d times uppercase A times uppercase G for Marvin, and the keys lowercase d, uppercase B, and uppercase H, uppercase B equals lowercase d times uppercase B times uppercase G for Swen. Note that Martin and Swen are using the same base point of G on the same elliptic curve on the same finite field. Number 2. Martin and Swen exchange their public keys, uppercase H, uppercase A, or times uppercase A, and uppercase H times uppercase B over an insecure channel. And you know, I think I'm reading that right, but I could be wrong. The man in the middle would intercept HA and HB, but would not be able to find out either lowercase d uppercase A nor lowercase d uppercase B without solving the discrete logarithm problem. Number 3. Marvin calculates at uppercase S equals lowercase d uppercase A, uppercase H, uppercase B, using his own private key and Swen's public key, and Swen calculates uppercase S equals lowercase d, uppercase B, uppercase A, uppercase H, uppercase A, using his own private key and Marvin's public key. Note that uppercase S is the same for both Martin and Swen. In fact, uppercase E equals lowercase d, uppercase A, uppercase H, uppercase B equals lowercase d, uppercase A times lowercase d, uppercase B, uppercase G equals lowercase d, uppercase B times lowercase a times uppercase A, uppercase G equals lowercase b d, uppercase B, uppercase H, uppercase A. The man in the middle, however, only sees HA and HB together with the other domain parameters and would not be able to find out the shared secret S. Before the transaction can begin, both Marvin and Swen must agree to transactional parameters A, B, P, and G. See Figure 3. Each party then generates a random integer to use as its private key. For Marvin, this is M, and for Swen, this is N. Each then multiplies the base point G by their private key to form a new point that represents their public key. In terms of an elliptic curve, remember that each point comprises an x-coordinate and a y-coordinate. Martin and Swen then exchange their public keys and multiply the other's public key by their own private key. This produces a new point, which is the same for each party. It remains only to convert this point to a bit string suitable for use as a key. Note: an eavesdropper may be able to observe the agreed parameters and may see the exchange of public keys, but he will not be able to determine what either private key is, nor the key that the two parties have agreed upon. Oh, a lovely diagram. A Verge Currency stealth address is a 95-character string that consists of a public view key and a public send key. When Marvin sent Verge to Swen, Marvin will use Swen's public view key and public spend key as well as some random data to generate a unique one-time public key, stealth address, for Swen's new output. Everyone can see the one-time public key on the blockchain, but only Marvin and Swen know that Marvin sent Verge to Swen. The output is created in such a way that Swen can locate the output destined for him by scanning the blockchain with his wallet's private view key. Once detected and retrieved by Swen's wallet, he would be able to calculate a one-time private key that corresponds with the one-time public key and spend the relevant output with his wallet's private key. This whole process occurs without having Swen's wallet address publicly linked to any transaction. Oh my god, that's so fucking elegant. 4.5 Key takeaways. Number 1. It is publicly unlinkable to the original public address. Number 2. It is publicly unlinkable to any other one-time address. Number 3. Only the recipient can link all their payments together. Number 4. Only the recipient can derive the secret key associated with the one-time address. Stealth addresses enhance user privacy in every transaction by allowing the user to create a one-time public key which automatically generates and records who can spend an output in a later transaction. Stealth addresses prevent outputs from being associated with the wallet addresses by effectively allowing users to transact outside of the publicly viewable blockchain. An outside observer has no way to tell if funds have been moved from one user to another, nor do they can link wallet addresses together. No. Nor can they link wallet addresses together simply by looking up a transaction on the blockchain. When Marvin sends Verge to Swen, the output Swen receives will not be associated with his public wallet address. Stealth addressing has built-in methods of ensuring funds have been sent by allowing the sender, in this case Marvin, to be able to verify that payment was sent by checking the transactional confirmation within his wallet. Swen can rest assured that no one else can see when or if any Verge was sent to him, so long as appropriate precautions were taken when transacting with multiple parties. 5.0 Atomic Swaps, which, yeah, I don't really care if they can do that one or not. Let me rehydrate here for a moment. Yummy. And we're on page 18 of 30, 5.0 Atomic Swaps. Atomic swaps, aka atomic cross-chain trading, are cryptographically powered smart contracts that allow for interoperability between Verge and other cryptos on a peer-to-peer on-chain basis without the need of a trusted third party. An atomic swap works in the same way users would send funds to one another, by allowing users to cross-trade different cryptocurrencies without relying on centralized parties. At their core, atomic swaps rely on check-locked time verified (CLTV), otherwise known as hash time locked contract (HLTC). 5.1 What is a hash time locked contract (HTLC)? A hash time locked contract is a type of payment in which two people agree to a financial agreement where one party will pay the other party a predetermined amount of crypto. These contracts are time locked, which basically means that the receiving party has a certain amount of time to accept the payment. Otherwise, the money is returned to the sender. These styles of payments can help to eliminate the need for third-party contracts, such as via contracts that are established between two parties. Third parties that are often involved in contracts are lawyers, banks, etc. Lawyers are often required to draw up contracts, and banks are often required to help store money that is then transferred to the receiving party, as stated in the contract. With HTLCs, two parties can set up contracts and transfer money without the need for a third-party involvement, or for third-party involvement. 5.2 How do hash time locked contracts work? The best way to describe them is the following example. Marvin wants to pay Swen for X via HTLC. Marvin sets up a specific hash which represents the amount of money that will be paid and an allotted time window in which Swen will be able to receive his funds. In order for Swen to receive the payment, he will have to create a cryptographic proof of payment within a predefined time limit. If Swen meets the deadline and procures the necessary proof required to release the funds, Swen is paid. However, if Swen fails to meet the deadline, the money is returned to Marvin. 5.3 What are the benefits of HTLCs? Number 1. As previously mentioned, HTLCs eliminate the need for third-party involvement when implementing a contract between two parties, which in turn also eliminates the need for third-party trust. Number 2. Since these contracts are time-sensitive, it prevents the person who is making the payment from having to wait indefinitely to find out whether or not his or her payment goes through. Also, it prevents money from being wasted, since if cryptographic acknowledgement is not obtained, funds are simply returned back to the sender. Because cryptographic proof of payment is required, the recipient automatically helps validate the payment on the blockchain. Number 4. Since hash time locked contracts are based on hashes, they are easily added to the blockchains. Number 5. Each party is protected from counterparty risk due to the structure of these contracts. The parties involved in sending and receiving the payments do not have to trust each other or even know each other to make sure that the contract will be executed correctly. 5.4. What are the benefits of atomic swaps? The primary benefit for users is the ability to exchange/trade cryptos between involved parties in a trustless manner without depending on a third party or an escrow service, thereby reducing default risk to zero. Additionally, atomic swaps make the entire cryptocurrency ecosystem currency agnostic, effectively simplifying the process of switching between different crypto depending on said crypto's use case. For instance, if you wanted to switch from Digibyte (DGB) to XVG or vice versa to utilize available features on our network or another crypto's network, the process would be instant and painless. I can see some sort of function there if you're actually trying to switch teams but not lose your monetary value at an agreed upon exchange rate. I can see some utility there. 5.5. What are the limitations of on-chain atomic swaps? With every implementation, there are several limitations that come into play. For atomic swaps, those limitations are as follows. Number 1. Both currencies that are being exchanged must have the same hash algorithm. Number 2. Since Verge supports multiple algorithms, we are less limited than other currencies in this regard. Number 3. Both currencies should support HTLC. If they don't, then you're fucked. Number 4. Individuals need a certain level of programming capacity to be able to use atomic swaps. Number 5. Cross-chain atomic swaps are not possible for fiat currencies. Yeah. Furthermore, this implementation not only allows for cross-chain transactions, but it also paves the way for future implementations such as the Lightning Network. It is important to note that while we do not have plans to implement Lightning Network onto the Verge blockchain, understanding the concept of LNs helps spread educational insights to interested parties. As such, the below segment about LN is strictly for educational content only. What is the Lightning Network? Yeah. And one thing, it also depends on how you're doing Lightning Network, because there are multiple ways to do it. The Lightning Network can briefly be described as number 1, a network of user-generated channels that send payments back and forth. Number 2, secured by smart contract functionality. Number 3, privatized in a trustless fashion. Trustless means you don't need to trust or even know your counterparty. Rather than transacting in a trusted fashion as you would normally do in a standard transaction, the Lightning Network transactions are completely trustless, which means that since these styles of transactions operate on top of a multi-signature based platform, participants remain anonymous and transactions are ensured to be secure due to smart contract capabilities. Yeah. Number 6.0, Rootstock, RSK. To understand the foundation of Rootstock, we must first understand what a smart contract is. A smart contract is a software application that operates on top of a blockchain that contains a set of mailable rules for which each of the participating parties to the smart contract agree to interact with each other. Smart contracts facilitate, verify, and enforce the predefined rules to execute decentralized and autonomous transactions. Let me check something really quick. Somebody was talking here. Yeah. Google that shit, dude. These contracts allow for more complex transactions to take place rather than simply exchanging digital tokens for a product or service. This means that the, quote, buyer and seller are both held accountable for the terms outlined in the smart contract and must uphold their respective ends of the deal to successfully transact between themselves. The predefined transactional rule set is formalized in a digital form, which is then enforced and automatically executed by a computer or network of computers as soon as the parties have come to an agreement and met the conditions of the agreement, which effectively removes third-party trust entirely. In short, smart contracts are self-verifying, self-executing, and tamper-resistant, and can turn legal obligations into automated processes while simultaneously reducing transactional cost and greatly increasing transactional security. And we're not going to review the diagram of how smart contracts work. The above-mentioned smart contract functionality is currently present and functional on the Ethereum blockchain network and does not allow for interoperability on the Bitcoin or Bitcoin-based networks. That being said, let's look at the Rootstock smart contracts and their benefits to Verge, Bitcoin-based network. Rootstock RSK is a two-way pegged sidechain that enables an Ethereum-style Turing complete virtual machine infrastructure, i.e. smart contract functionality, onto Bitcoin-based blockchains. A sidechain is an independent blockchain that is attached to the main chain using a two-way peg. The two-way peg allows for interchangeability of assets using, in this case, Smart Verge as XVG and Verge at a predetermined rate between the main blockchain and the sidechain. With the addition of the RSK sidechain also comes the implementation of merged mining to support it. Merged mining allows a miner to mine for more than one blockchain at the same time, effectively utilizing the hashing calculations they already contribute to fuel both chains. The RSK sidechain can be merge mined with Verge, meaning that machines mining Verge don't have to use any additional power or resources to participate in securing and maintaining the RSK network. Miners are rewarded with transaction fees from the RSK network on top of the Verge that they already mined so long as they are participating in merge mining. Merge mining inherits these same security features of Verge in terms of double spend protection and settlement finality. That's interesting. For a user to obtain SXVG, they must first send their XVG coins to an output address where the coins become locked such that the user is unable to spend them elsewhere. Once the transaction is completed and confirmation has been obtained, the sidechain releases the equivalent number of SXVG coins to the user, allowing them to access and spend them on the sidechain. It is important to note that during the interchange process, no new coins are minted. One SXVG will always equal one XVG and vice versa. The additional benefit of RSK is the ability to scale. RSK currently achieves 300 payment transactions per second, which is a huge progressive leap when compared to our current standing transaction rate of around 100 per second. The RSK development team has stated that the eventual goal is to push the bar even higher, with future goals to support 20,000 transactions per second using second layer technology called Lumino. As stated in the LCTP white paper, the Lumino network is an off-chain payment system that relies on a protocol known as the Lumino Transaction Compression Protocol. The LTCP can be compared to the Lightning Network, a scaling solution originally designed for Bitcoin that is currently being tested on Litecoin. RSK functionality is going to enable developers outside of the Verge core development team to build exciting platforms and services on top of the network. You know what? I can like sense some sort of underlying attack vector there, where they're just mining the side chain or whatever, and they swap them for regular Verge at some point. I don't know. I can sense it. It's there. Some examples of these platforms could be: number 1, decentralized applications; number 2, retail payment systems; number 3, escrow services; number 4, asset securitization; number 5, decentralized remittances; number 6, microlending platforms; and number 7, voting systems. Additional use cases and information can be found on RSK's white paper. Disclaimer: a smart contract is currently defined as in such legislation as an event-driven program or computerized transaction protocol that runs on a distributed, decentralized, shared, and replicated ledger that executes a contract or any provisions of a contract by taking custody over and instructing transfer of assets on a ledger. As such, Verge, the developers and core team members of Verge, cannot nor have the ability to modify or regain custody of funds that are placed in a smart contract. Well, that's cool. Page 24 of 30. 7.0 Ring Confidential Transactions. Important note: Ring Confidential Transactions are still under development. The information contained in this segment is for the purposes of education. This document will be edited later to include more information as required regarding Ring Confidential Transactions. Before we begin to dissect and understand the complex nature of Ring Confidential Transactions, we must first understand the fundamentals behind what a transaction is and the differences between each mechanical component. The root of each Verge transaction is based on a sequence of immutable Python objects in list format, which cannot be changed, otherwise known as the nth tuple. In this case, the basic nth tuple of a transaction is as follows: AI, BI, VI, where AI are input addresses, BI are output addresses, and VI are the amounts that go to each output. Every basic transaction made on the Verge blockchain comes across as unencrypted data for the entire world to see on our public ledger. While this is good for merchant service platform integration, it is not ideal for people concerned about their privacy, as these transactions are easy to trace regardless of how many times the coins change owners. The primary goal for confidential transactions is to ensure that only participants of a transaction are privy to the values being sent back and forth, while simultaneously hiding the values from the sight of the rest of the world. At the same time, however, we want non-participants to be able to tell when a transaction is bogus. There are several cryptographic concepts that need to be covered to be better able to understand how anonymity is maintained via confidential transaction, while simultaneously being able to verify that the sum of outputs doesn't exceed the sum of the account contents of input addresses. 7.1 Ring Signatures. To preface this segment, ring signatures are comprised by a series of complex mathematical equations that can easily be described as a dry and hard to comprehend topic. For the sake of keeping the space of this paper on par, if you are interested in seeing the mathematical equations that are associated with ring signatures, as well as a further deep dive into these materials, I will be listing those materials in the references segment of this paper. Otherwise, the following is going to be a brief and to-the-point introduction to ring signatures and their benefit to Verge Currency. In cryptography, a ring signature is a group-based digital signature like threshold signatures. Ring signatures can be performed by any member of a group of users that each have keys. Therefore, a message signed with a ring signature is endorsed by someone in a group of people. A shared cryptographic signature proves the authenticity and integrity of a transaction from a single user. Think of this as the same way you might sign a check identifying that you approve an expenditure. For group signatures, instead of showing that a transaction is approved by a single user, ring signatures allow anyone in a fixed group to sign a transaction. It is worth noting that while it only takes one person out of a fixed number of participants in a ring signature group is determined by the ring size. Ring size effectively determines the anonymity set for a signature. The larger the ring size, number of participants, the harder it is for someone to de-anonymize the transaction. To give an example of ring signatures and ring size, Marvin wants to send a transaction to Swen with a ring signature size of 4. This means that there's a total of 4 participants in that group, of which Marvin and Swen make up half of the possible participants. While this transaction is in fact anonymized, the small number of participants weakens the anonymity guarantees of the network. Conversely, Marvin wants to send another transaction to Swen, but instead of having a ring size of 4, the ring size is now 30. This would indicate that there are 28 other group members, thereby vastly increasing the anonymity guarantee associated with initializing a ring signature-based transaction. To summarize, ring signatures obscure the linkage between sender and recipient, but do not obscure the amount sent during the transactions. Even though values are not obscured, there is no way an outside observer can differentiate which of the members in a signature group is the original signer of a transaction. Therefore, one of the primary security properties of a ring signature is that it should be computationally infeasible to determine which of the group members' keys was used to produce a signature. 7.2. Penderson Commitment. One of the basic tools that confidential transactions are based upon is something called a Penderson commitment, which is a cryptographic algorithm that allows a prover to commit a certain value without revealing it or being able to change it. As explained by Gregory Maxwell, Penderson commitments are a commitment scheme that allows you to keep a piece of data secret, value of the transaction, but commit it so that you cannot change it later. For example, Marvin has an output value of 30 XVG and wants to send 15 to Swen. Since outputs can't be spent twice, Marvin needs to spend the output in its entirety and return the change to himself. Marvin's transaction has one input of 30 XVG and 2 outputs, 15 XVG for the actual transaction designated for Swen, and 15 XVG returned to Marvin as change from the transaction. To prove that the Verge has not been fraudulently fabricated in the transaction, a sum of a transaction's inputs must equal the sum of the transaction's outputs. Penderson commitments enable you to send Verge without publicly disclosing the amount sent by sending a specific data segment to the network, which makes it possible for miners to verify the transaction. It is worth noting that the information segment that is broadcast across the network is a long chain of random numbers with no significant data points that would lead an outsider to be able to determine the value of how much Verge was sent during the transaction. 7.3. Range Proofs. Before we can understand what a range proof is, let's briefly review the concept of a zero-knowledge proof. A zero-knowledge proof is a method by which person A can prove to person B that they know a value X without revealing or stating any information except for the fact that they know the value X. To specify, a range proof is a zero-knowledge proof that serves as a form of commitment validation that allows anyone to verify that a commitment represents an amount within a specified range without revealing anything else about its value, known as the secret value. For example, when Marvin sends Swen an amount of Verge ranging between 10,000 to 100,000, a simple range proof can be used to validate the amount sent without revealing the actual amount publicly. This concept has important ramifications for the validation of confidential transactions, as it is used to verify that a payment amount is positive without revealing the amount transferred in a transaction. Furthermore, in a transaction output-based system, it proves that the commitment inputs are greater than the sum of the committed outputs without revealing either the committed inputs or outputs. It's important to note that all modern implementations of confidential transactions use range proofs over committed values, where the proof size is linear in n, and additionally note that this technology is not specific to Verge. Conclusion: Verge was created to bring tailored transactional applications and inherent privacy applications or implementations to strengthen user obfuscation while maintaining Nakamoto's vision of a decentralized electronic payment system based on cryptographic proof instead of third-party trust. Whether simple, stealth, or anonymous, all transactions are cryptographically secured and proven on our publicly facing blockchain. Verge is completely user-controlled and decentralized, which ensures that at no point in time is your transactional metadata going to be shared or sold to independent third-party corporations, assuming, of course, they aren't involved in your transactions themselves. When you make a purchase with Verge, your personal privacy is kept safe. One of the key points behind Satoshi Nakamoto's original vision was to provide a solution that defied the standard convention, a cryptographically secure digital currency that can be trusted because it is trustless, a pure peer-to-peer version of e-currency that allows online payments to be sent directly from one party to another without going through a financial institution. Through an unfortunate series of events as well as progressive financial institutional adoption, the core values of Bitcoin are slowly dissipating as the currency becomes more centralized and controlled. One of the primary factors that influence the centralization of Bitcoin is its limited circulating supply. Bitcoin has a predefined cap of 21 million coins that will ever be in circulation, with today's circulating supply being around 17.5 million coins. Limited supply as well as progressively increased demand from mainstream channels such as financial institutions like JP Morgan and various other forms of large-scale investors ultimately contribute to the centralization of something that was meant to be decentralized. Verge solves this issue by having an overall supply cap of 16.555 billion coins. We seldom realize the value of something until it has been lost. We want our lives to be our own and to determine for ourselves what we want to do with them. The desire to pursue personal interest without compromise. What most people don't realize is that the pursuit of these external interests opens us up to vulnerabilities in the public space. And that was by CryptoRec there. Our large endgame circulating supply and widespread distribution will keep Verge decentralized. As the overall value of Verge increases over time, there will be further distribution of wealth amongst token holders, further increasing the overall level of decentralization. Nakamoto's original vision. And we're not going to go through all the references, and we are done, kids. That was the Verge Currency black paper. And, I try to be as, how should I say it, objective as possible when reading these materials, whether they be for Verge or any other currency. And, in the overall scheme of things, I really see the pursuit of overlay services and whatnot to be relatively limited, but that's just my own perspective. I really think that one of the problems with cryptocurrencies these days is that many people have forgotten that adoption means mining too. It doesn't just mean running a non-mining node. It doesn't mean just having a wallet with some Verge or Bitcoin or Litecoin or whatever in it. It doesn't mean just trading it on a cryptocurrency exchange. And it doesn't even mean just hodling it. It means that you need to be mining it. You need to be contributing to the overall strength of the network, both for its security and the security of your own funds. These are the incentives that underlie all the reason to participate in this. And I think it's one of the set of incentives that's really underplayed. And honestly, I didn't hear as much of it as I would have liked to have heard in this black paper. But nonetheless, I think it was kind of appropriate only because we're trying to talk about the actual functionality and the options of capabilities you could utilize with this currency as opposed to, you mining it. Nonetheless, I do feel that that's the really important part of cryptocurrencies, man, that a lot of people miss. It's because when you're mining it, you actually get to see it in progress. You understand what your participation actually means, and you get to see other people participating in it. Anyway, let's go ahead and throw back down into some music, as we've only had just the one music break today. And, this is coin metal. We talk about the coin and we play the metal. So as far as what to play, though, that's always a challenge. And so, I don't know, I'm feeling the need for some Slayer, because, it's been a little while. And, so yeah, as far as which one, though, this is one that when I play it, people seem to like it a lot, so here it is, Slayer, Deviants, here on Coin Metal. And that was Powerman 5000 with When Worlds Collide. Anywho, and so we got through the entirety of the Verge BlackPaper. I might have misread the little math parts. I swear I got to go get like a math tutor in like a blackboard and relearn all the shit so that I can actually read this stuff when we get into the cryptographic shit in like straight linear format, like it's just a little paragraph, because I know that's how it reads to somebody on this planet. It's just not me. At least not yet. But that can change. That's not a permanent feature of me. I learned how to read English. I'm sure I can relearn to read math. Anywho, but yeah, we've been talking about Verge Currency and some of the attributes that it's getting with this new revision that's coming out, and apparently it is released and available on GitHub in alpha form, recommended pretty much for the devs at this point. But yeah, if you think you got something you want to add to it, I'm sure they're taking suggestions still. I don't know. Anyway, because the focus of Verge, ultimately, at least a part of it, is to guarantee some greater level of privacy than traditional methods of transacting, even within the cryptocurrency space. And I think that's going to be really important in the near future. That there are organizations, governmental and otherwise, that are paying a little more attention to the blockchains of cryptocurrencies. I was going to say certain, but I'm sure they watch all of them at this point. And trying to pay attention to exactly what we're doing. And in all honesty, I think that it's the concern is overblown, but it's overblown because of the people who are interested, specifically like bankers and financiers and all that other shit, and little people like you. And because pretty much anybody can be interested in it, there's some level of interest everywhere. And in any case, where I was going with the whole privacy-focused centric thing was, it probably would have helped out in this situation. And we cover a lot of data breaches on this show because I think a lot of people are placidly unaware of the level of fuckery that's going on out there with regard to their data being nailed from their cellular service provider, from what was that one, Equifax, from the IRS's Edgar database. There's a lot of shit going on out there. There's a lot of people's private data that in all regard probably shouldn't even be retained for any reason whatsoever. But, it is being retained, and because of that, it's vulnerable to somebody hacking it and ganking it. And so, here we go. We are on Bloomberg Business. BlackRock exposes confidential data on thousands of advisors on iShares site. And this is by Annie Massa, so no penis. This is authored January 18th, 2019, 5:36 p.m. PST, updated on January 18th, 2019, 7:52 p.m. PST. Thank you very much, Annie. I love it. Thank you. Not only told us when, but where on planet Earth you wrote this. Thank you very much. I appreciate that. Continuing on. BlackRock Inc., the world's largest asset manager, inadvertently posted confidential information about thousands of financial advisor clients on its website. The data appeared in 3 spreadsheets linked on one of the New York-based company's web pages dedicated to its iShares exchange-traded funds. The documents included names and email addresses of financial advisors who buy BlackRock's ETFs on behalf of customers. They also appeared to show the assets under management each advisor had in the firm's iShares ETFs. The links were dated December 5th, 2018, but it's unclear how long they were public. The documents were seen by Bloomberg and removed Friday. BlackRock, which oversees assets of almost $6 trillion, is the world's largest issuer of ETFs. One of the spreadsheets appears to list more than 12,000 entries of advisors and their sales representatives at BlackRock. On another, the advisors were categorized in a variety of ways, such as dabblers, power users. A column noted their, quote, club level, including, quote, Patriots Club or Directors Club. Pledging review. Quote, "We are conducting a full review of the matter," spokesperson Brian Beads said in a statement Friday. Quote, "The inadvertent and temporary posting of the information relates to 2 distribution partners serving independent advisors and does not include any of their underlying client information. Securing data is known to Wall Street leaders keep... Oh, you fucker. My apologies, Annie, but you left out a word here. It's supposed to read, securing data is to Wall Street leaders... is known to keep Wall Street leaders awake at night. Yeah, you left out keep between 2 and Wall Street. Known to keep Wall Street leaders awake at night, but most often senior executives cite a fear of hackers, which has prompted some of the nation's biggest banks to pour upwards of $1 billion a year into cybersecurity. It's one area where financial firms set aside bitter rivalries share tips, and collaborating on projects to ensure the public remains confident in the industry and it never suffers a catastrophic loss. But even more data breaches don't expose client assets, risk reputational harm. But even data breaches that don't expose client assets risk reputational harm. There was a need for a comma in there somewhere, and you missed it. In 2014, J.P. Morgan Chase & Co. suffered one of the industry's largest losses. And one thing, I don't want to seem like I'm beating up on Annie here, but she is in Bloomberg. There were quite a few little side edits that I did there in the Verge BlackPaper. They were tiny. They were just like missed words and shit like that. But my apologies, Annie, if it feels like I'm bullying you here. But really, you're on Bloomberg. Gotta edit like it. Read your shit aloud. It helps. 2014, J.P. Morgan Chase & Co. suffered one of the industry's largest losses of information, estimating at the time that hackers had accessed contract information on more than 80 million clients. Chief Executive Officer Jamie Dimon vowed to increase the bank's security budget and embarked on a hiring spree to build out those operations for what he called a, quote, permanent battle. He has repeatedly updated investors on those efforts in annual letters. Firms can't avoid breaches entirely, but they can react to them in a way that rebuilds trust, said John Reed Stark, who focused on internet crimes while working in the Securities and Exchange Commission's Enforcement Division and now runs a cybersecurity consulting business. Quote, data security incidents are inevitable, he said after the incident at BlackRock. Quote, the most important thing in this kind of situation is about the response from the firm and whether they're communicating accurately about what happened. Yeah. That's keenly important when we're talking about maintaining the trust of your clients. Because they do put a lot of trust in you. Thank you very much on that, Annie. But yeah, as far as data breaches, there are, I believe at least, certain data breaches that you can mitigate entirely. As we've talked about with Verge, you could make your transactional history pretty much transparent and accessible to your users, while at the same time entirely secure, and be retaining some sort of record on that. That's an option that is available now. You set up, as we talked about with Verge, you set up a smart contract with them, and you have the funds tied up. They can't respend the funds. Nobody knows who the funds are. Come on, man. This is not rocket science. And more importantly, you don't need to spend $1 billion fucking dollars on your goddamn security apparatus. Now, you could probably spend like, $1 billion. I want to say about a couple million. Spend a couple million on a goddamn warehouse. Set up some miners for different currencies that you're going to use at different points for different things. And that's just, I'm sure you guys can afford it. But that would more or less replace like 90% of all the fucking security bullshit that you're having to keep. Whereas you could have just files associated with transactions. And you could have the goddamn files encrypted entirely. So even if the stuff gets compromised, it's inaccessible, it's useless. And when people talk about blockchains and whatnot, again, I think a lot of them talk about them in terms of something that the public can't participate in. Look, compete with us to store your fucking data. We'll gladly do that. If there's an incentive involved that we can cash out on, that we can make money on, that we can profit from, fuck yeah, we'll do it. That's the whole game here. But if we don't have any interest in it, if we don't have any stake in it, if we aren't actually dedicating any hardware or electricity or time or bandwidth, if we're not dedicating anything, if it's not actually costing us anything, I think that's one of the places where our interest is lost. And of course, you just have to make it as easy as possible for people to participate. Really simple GUI on your mining software. Really low demand on the system requirements to participate, and a profitable return for participation. I don't think these should be terribly difficult to manage. And like I said before, multiple times on the show, I do expect another alt bloom to happen at some point or another in the not so distant future, where people are going to be taking a look at the lessons that have been learned over the last decade and just starting brand new with as many of the fixes as they can possibly fit into a project, and just trying to gank the ring on their own merits. I'm absolutely certain of that. And I'm absolutely certain that more than one group is actually going to try that. There's incentive to do so. That's the initial incentive, rather. But whether or not people express the interest that you would like them to in your project, or go with you on certain developments in your project, that's entirely up to them. And that's one of the things that I liked about the services and additional stuff that they're talking about on the Verge BlackPaper, is that most of them are optional. It's like, if the network never utilizes any of them, it doesn't suffer. It's still going to be mining Verge. It's still going to be logging Verge transactions on the blockchain. But it's not going to actually suffer. Now it'll improve. I mean, it'll grow in value as more people use it. That's a whole different thing. Its functionality is there for use or non-use. It's optional. And with the additional capacity of the network that it actually has, it's actually 20 times the Bitcoin network's throughput capacity. Because of that, I think that in the near future, should Bitcoin become too expensive for most people to transact on chain, that people will start looking around. They're at least savvy enough to have Bitcoin, right? If they're savvy enough to have Bitcoin, they're savvy enough to know how to exchange it for other coins, or that other coins actually exist. And of course, there's going to be scammery and fuckery and all that other bullshit, but we're talking about humans and we're talking about money. So that's a foregone conclusion. You just got to assume that there are people out there to fuck you over. But when you're evaluating a project and you look at how it actually functions by participating, you have that much more assurance of what exactly is going on. I think that's one of the problems, is that if you're not mining it or whatever, it's purely conceptual for you, at least on one aspect of it. If you're not competing for the coin, then it's purely conceptual for you. Even if you're trading it on a goddamn exchange or whatever, or even using it for money. But yeah, that's why I keep stressing that. I think that kinetic aspect of it, the real world cost involved in providing a decentralized network, I think that reflects the stake that other people are putting into it as well. Even if you are competing with Bitmain or whatever, you're looking at the amount of hashing power they're dedicating to it, and you're looking at the amount of hashing power you're dedicating to it, and you're like, yeah, I can understand why they get the block reward as often as they do. It's not something where you're looking at it from the outside and you're saying, "Oh, fuck Bitmain, those guys are assholes." They're only providing 30% of a network or 30% of the power for the network that we're all talking about. That's been in existence for a decade and continuously been running. Yeah, something that big as far as an actual commitment of stake. Put a little bit of skin in the game. You would think that would be lauded. You would think people look at that and go, "God damn, that is awesome of him to be throwing around that much money on hardware and whatnot to make sure that we have a secure blockchain." But again, most people don't understand the real world costs of mining. And if we did, we'd have greater appreciation for it, I think. But yeah, so BlackRock doing a lot of their business on cryptocurrencies or in cryptocurrencies, I think would resolve a lot of the demand or, a lot of the issue that they have with regard to their security apparatus. Probably simplify the shit out of it. As far as the fiat side, that's not something that they can control there, but nonetheless, yeah, BlackRock might consider Verge. Anywho, we've got a little bit of time left. I got a few more tabs open. I think we can go into it here. Let's see here. No, I don't really want to talk about that or that. Go ahead and close that one. No, not that one. And actually, I've pretty much got everything I needed out of that one. Oh, what's this one here? No, that one's done. Ooh. This is interesting. Let me get a drink of water here. Yeah. So I got this thing on coinspectator.com. This is published 1 day ago. New UK Bitcoin exchange overwhelmed by crazy demand amid Brexit uncertainty. Now Hong Kong-based Binance, the world's largest Bitcoin and cryptocurrency exchange by trading volume, has said it has been overwhelmed by registrations for its New Jersey-based trading platform, which the exchange's widely respected chief executive, Changpeng Zhao, CZ, put down to, quote, crazy demand. Meanwhile, the UK is stuck in Brexit gridlock as it struggles to find a path out of the European Union following its decision to quit the trading bloc over 2 years ago, playing havoc with the local financial markets and casting doubt over the country's future as a traditional banking hub. The Jersey-based Binance trading platform is expected to bring a fresh wave of competition for the likes of the Coinbase and Bitstamp exchanges, both of which serve the local market. Getty Binance Jersey, which opened for registrations on Tuesday this week, will allow users to trade euros and British pounds with Bitcoin and Ethereum and access digital asset management services. Binance has said it expects the island of Jersey, which is a self-governing dependency of the UK, to be a major driving force of increasing cryptocurrency use in the European market, with Brexit part of its reasoning for expanding into the region. Quote, expanding the cryptocurrency exchange markets with fiat currencies in the European region is opening new economic opportunities for Europeans, as well as freedom from looming Brexit uncertainty, where the pound and euro are also in concern, said Binance Chief Financial Officer Wei Zhao. Cryptocurrency take-up in Europe has so far been sluggish compared to U.S. and Eastern Asian markets. However, with daily Bitcoin exchange volume on the continent less than 4% of the global volume late last year, according to CryptoCompare, a data provider. Let's see here. Bloomberg Finance LP. Over the last 2 years, the UK's financial sector has repeatedly warned it could be wiped out if the country leaves the EU. Without a trading deal in place, a situation that's become known as a hard Brexit, earlier this week, the head of the industry body UK Finance, which represents banks and financial services, warned crashing out of the EU without a deal would be catastrophic for the country's banking industry, which rivals New York's as the world's biggest financial hub. The Bitcoin price is still nursing a hangover after its epic 2017 bull run. CoinDesk, while interest in Bitcoin cryptocurrency and alternatives to the traditional financial industry remains strong in the UK. Let's see, read the whole thing, and where are we at on this? I hate it when it's a different format entirely from the... This is actually on Forbes. Let's see, where's it at? Over the past 2 years, let's see. Do I have to start this thing all over again? No. There we go. Over the last 2 years, the UK's financial sector has repeatedly warned. We already got that one. Earlier this week, the head of the industry, UK Finance, which represents banks and financial services, warned crashing out of the EU without a deal would be catastrophic for the country's banking industry, which rivals New York's as the world's biggest financial hub. Elsewhere, a disorderly Brexit would plunge the UK into recession for at least 2 years and lop a half percentage point off of the entire EU's economic output, according to Deutsche Bank chief executive Christian Sewing. The governor of the Bank of England, Mark Carney, warned in November last year, the pound could fall a quarter in the event of a no-deal Brexit. British Prime Minister Theresa May is now battling to find a cross-party compromise to the Brexit standoff after the deal she struck last year with the EU was rebuffed by lawmakers, including many of those in her own party. While interest in Bitcoin, cryptocurrency, and alternatives to traditional financial industry remains strong in the UK and Europe, that interest has done little to support the Bitcoin price. Bitcoin remains trapped in a bear market that has wiped out billions from its market value and seen the price per Bitcoin fall to around $3,500 from almost $20,000 a little over a year ago. Quote, "During the bull market in 2017, we definitely saw a strong interest in Bitcoin from UK clients following the Brexit referendum. However, now that price direction is a bit more uncertain, it's more difficult to identify such national trends," said Maddie Greenspan, senior market analyst to broker eToro. Yeah. So, I don't know. I've always wondered about the whole Brexit thing, if it's actually ever going to happen. I mean, supposedly they're going to be chewing on it for a little while longer. But I don't think that they can figure out whether or not they want to get out of the euro. Or, the euro. And it's something that I kind of predicted would happen. Only because... The fact of the matter is there's several different countries and several different actual national cultures involved in those countries that put them at different paces in their industrial development and their financial development and so on and so forth. And so, expecting them all to be able to be housed under one financial instrument like the euro, I believe was unfair to the more productive countries in the fact that they would always be carrying the weight of less industrial nations, and we're seeing that. You know, we've seen the worst of it in like Greece, in Portugal, and Spain, where they're just not at the same pace as as the UK or, you know, other members of the EU Union. But, you know, now that we do have cryptocurrencies, I don't think the interoperability issues that people were facing prior to the euro are going to be as big an issue as they previously have been. You know, determining international exchange rates for currencies is not a big issue. You know, if we can determine the exchange rates of fiat currencies one for the other digitally, and we can on top of that compare the cryptocurrency price within each of those national borders, we could come to a synergy where we're able to find a price on either side of the exchange rate there, and determine an exchange rate for Bitcoin for, you know, whether it be pound or US dollars or, you know, the remaining members of the euro or whatever it is. You know, Deutschmarks. You know, if France were to go back to their traditional currency, and these are all things that are now ephemeral differences. You know, they're a matter of calculation that we can do. You know, I mean, it's not something that is as impossible as having to burst each fiat currency on hand, you know, in real time. Which is fucking impossible, because you have to actually have physical delivery of the coins and the paper notes and all that other shit in order to fully settle everybody's commitments. But, you know, we've been transitioning in the finance sector anyway to a more digital format. And not to say that physical notes will ever fully go away, but their relative value to one another, and of course commodities on the open market, I think may be affected a little bit. I don't know. In the long run, I really expect physical notes to be probably the easiest means of transacting monetary value, like whether that be exchanging actual physical private keys or not. I don't know. We will find out one way or the other. Man, it's a long episode, mostly me reading. But yeah, as far as the euro, inevitably I do expect it to go extinct. You know, because one of the things that's lost when you put that much value and different values under one nest is the individual values of each party. You know, it's like, sure, Greece doesn't have the production capacity of say, Brussels, or I don't know all the members of the EU, so I have a little hesitation to just rattling off one. But other players, right? They have other things about Greece that put them on par, you know, such as their services in Greece, you know. So like when you go to Greece, you have amenities and whatnot. The quality of those amenities versus other places, that puts them on a different differential. I mean, a value differential. You know, if we're assessing all of the values of these places individually, we can see that they're equal, if not exceeding, the relative value of these highly developed manufacturing bases. Countries, that is, manufacturing based countries, or economies rather, because there is demand for these things. You know, there is demand for a really nice place to go on vacation where you don't have to worry about a whole lot, you know, because you got all kinds of services around you to deal with shit. You know, there's a value to that. And you know, when we're trying to place it all under the rubric of one monetary unit, where on the other side of it you've got these hyper-industrialized sectors or countries, you know, it's not fair. the ones that are producing more are always going to be pulling the ones that aren't producing as much. Again, on the manufacturing base. But if we were to take into account fully, say Greece or Portugal's other quantities or other values, we find that they even out over a intermediated market. I don't know what I'm trying to get to there, other than I think that cryptocurrencies would make transacting monetary value between countries so much easier that a euro really isn't fucking necessary. They could do atomic swappers or whatever the fuck. But it is with that I do want to close out this episode. Thank you very, very much for listening. I certainly do. I do appreciate the support. Until Monday, we will be back again on Monday at 8 p.m. Pacific Standard Time. And until then, you can always find me on Twitter, on Facebook, and in the Telegram and Discord channels for Verge Currency. And so until Monday, I want y'all to trade safe. Do your homework. Watch out for your own bunghole, because nobody else is going to do it for you. Thank you again for listening, and y'all have an excellent weekend. As far as our last dance is concerned, we didn't do any Tool, we didn't do any textures, we didn't do Testament. I don't know, I'm having a little difficulty choosing this one, but I think I know which one to go with. Let's go up to the top here, or at least closer to the top. No, not that one. I was going to pick the song that's currently playing, but it's not quite the appropriate one. Damn it, Jim. I'm on the spot here, and I can't crank out a song out of all the stuff that I have available. Gee willikers. I know I already played some Megadeth. I already played some of that. And of course, I'm not getting any suggestions. Here we go. Killing Joke, Loose Cannon, Last Dance here on Coin Metal. Thank you again for listening, and you all have an excellent evening.